Okay folks, so video 2 on completing the square. You'll see that we're being asked to work with a negative x squared parabola now. So we've got the equation 9 minus 4x minus x squared. So if we were to draw that, it would look something like this. Okay, we're working with a maximum turning point. And we didn't do this at National 5. We could have. Okay, it kind of would just about be National 5 work, but it's not in the course because they just deemed that with the kind of extra negatives floating about, it's just a wee bit too tricky. So we've got 9 minus 4x minus x squared, and we're asked to write it in the form p minus x plus q squared. Now, the method that I'm going to show you for this and in the next video, we could have shown you at National 5 as well to do the kind of easy ones, for want of a better phrase, that you've seen in the first video. And I often do teach it as an alternative, but the algebra is maybe a wee bit complicated for some people who are doing National 5. But because you've managed to come on to higher, okay, it's something that we think you would cope with. Now, what we're basically saying is we're taking 9 minus 4x minus x squared, and we say we want to write it so that it looks like this. And remember, p and q might be a and b. Okay, you'll see different letters used, it doesn't matter. What we're going to do is we're going to ignore our left-hand side. Okay, that's what we're trying to change, and we're going to play about with the right-hand side. Now, when I say play about in maths, I mean do some algebra. So we're going to multiply it out. Now, we need to be really careful here. So what we've got is we've got x plus q all squared. Now, remember, that means x plus q times x plus q. But we're being asked to take that all away from p. So to make sure we don't make any mistakes, I'm going to ask you to put an extra set of brackets around that, because that takeaway is going to have a huge effect on what's going on here. So we've still got the p at the front. Oh, wait a minute, let's go back to the right colour. We've still got the p at the front. Okay, and we are going to take away from that the thing that's in these big square brackets. If we multiply out x plus q times x plus q, we get x squared plus qx plus qx. So that's plus 2qx and plus q squared. So it's a wee bit algebraic here. If you weren't sure about that, remember x squared plus qx plus qx plus q squared. That's what we're effectively doing here, if I can just squish that in at the side. So this part here is giving me plus 2qx. Now you're going to do this for all of the questions on the worksheet. So by the time you've done it 5 or 6 times, you'll feel much more comfortable with this, hopefully. But if not, as usual, just let me know. Now, p minus x squared then, but we're taking away the 2qx, so minus 2qx, and we're also taking away the q squared, so minus q squared. Okay, now what we're going to do next is a little method called collecting coefficients. Okay, so what we want to do, oh, that's not how we spell coefficients. There we go, you kind of get the general idea, folks. We are saying that 9 minus 4x minus x squared, what we had on the left-hand side up here, okay, if we just look at that, is equal to, now, this is just a number, it doesn't have any x's with it. So what we want to do is we want to go along this whole phrase here and work out what is just a number, okay? So p is just a number. It doesn't have any x's or x squareds or anything with it. So I've got p. I've got minus x squared. That can't be used. I've got minus 2qx. That can't be used because it's got an x on it. But this minus q squared here, okay, this minus q squared that I've now shaded in blue with the orange circle around it, okay, that doesn't have an x associated with it. It's not in front of an x or an x squared, so that's also part of a number. So p minus q squared is just a number, okay? I've then got minus 4x here, so I'm looking at this that I've got left, and I'm saying what matches the x, what's just an x. So I've got minus 2qx, okay? And then here I've got minus x squared, on this one, let me do this in green, and here I've got minus x squared, so that's fine, they match. So what I've done is I have rearranged that line so that it matches the left-hand side. So now my left-hand side and my right-hand side look very similar. And what we can say is we can say that this 9 here must be the same as p minus q squared. Okay, so this might be a totally alien concept to you at the moment. Like, why does this work, Mrs. Knack? And if we had a little bit more time, we were in the classroom, we would do some more of a more basic example first. But we've got p minus q squared must be 9. Now, if we look at the bit circled in blue, that was minus 4x. And here, I've got minus 2qx. So what that's telling me is minus 2qx is minus 4x. And we could clearly, hopefully you can see, just get rid of those x's. Don't really need them. So we're saying that minus, let's put the proper pen on. We're saying that minus 2q is minus 4. Okay. And then negative x squared is negative x squared. Well, that's fine. Okay, they both match. So, because we're only trying to work out p and q. So if we look at these two equations then, negative 2q is minus 4. So we can divide both sides by negative 2. That will leave me with the answer that q is 2. Now that I know that q is 2, I can put that in here. So I've got p minus 2 squared equals 9. So p minus 4 equals 9. So p must be 13. So what's the answer I'm looking for? It tells me that 9 minus 4x minus x squared is equal to p, so 13, minus bracket x plus q, which in this case is 2, squared. And if you don't believe me, take this, multiply it back out, and you should get this. Okay, so 13 minus x plus 2 squared, because it was p minus x plus q all squared if we go back up to the start here. Okay, so the bit that's possibly the most complicated once we get the hang of this is just the algebra bit at the start here. Okay, once you're a wee bit more confident on it, this collecting coefficients will be a wee bit easier. Okay, we're going to do another example. I'm just going to check we've got enough space. We're a wee bit tight. Okay, so I'm just going to clear the board and start again. If it'll work, here we go. Okay, so second example. I'm going to ask you to write 6 plus 6x minus x squared in the form b minus x plus a all squared. Okay. So we keep the left-hand side the same. We can't really do anything with that. And what we're going to do is we're going to multiply out the right-hand side. Okay, so we've set the two things equal to each other. And we're going to multiply out this right-hand side. Now remember what I said before. We need like an extra set of brackets around this to make sure we don't go wrong. Okay, and we're doing x plus a times x plus a. So I'm just going to keep that in red just to remind you of what we're doing to begin with. Okay. So I've got b minus, now this bit in the brackets is going to be x plus a all squared, or x plus a times x plus a. X times a plus it times x plus a, x squared plus ax plus ax plus a squared. Okay, and then I'm going to have from there b take away. Still not dealt with the bracket and the negative yet. Okay, I'm going to tidy it up first of all. X squared, ax plus ax is 2ax, and plus a squared. Now I'm going to take this negative all through here. Okay, so I've got b, I've got minus x squared, I've got minus 2ax, and I've got minus a squared. Now if up here we'd had a negative, this would have been a minus, so we would have had a double negative to make that a plus. So just watch out for two negatives in the bracket. Okay, now from there we need to collect everything up a little bit better. So the two things, remember this is equal to 6 plus 6x minus x squared, so I'm just going to write that there so when I scroll up I can still see it. we want to bring together everything that's just a number. So the b and the minus a squared stand for just numbers. They're not attached to an x, they're not coefficients of an x or an x squared. So we've got b minus a squared as like the number. So when we compare, we're going to be comparing that with the 6, because the 6 is just a number. Okay? We've then got minus 2ax. That's the bit that's got the single x, the x to the power of 1 effectively. So the minus 2ax is going to match the plus 6x, because that's the bit that's the power 1x. And then we've got the minus x squared on the end with a minus x squared on the end. So, excuse me, that is where we're going to be. And from there now, we're going to compare coefficients. So I've kind of done some colours to try and help us with this. So if we compare the purple stuff, we're saying that 6 is the same as b minus a squared. Now I don't know b or a, so that's not very helpful at the moment. But if we look at the part in red, we're also saying that 6x is the same as minus 2ax, or we could just say that 6 is the same as minus 2a. Now, how do we solve that? Divide both sides by the number in front of the letter. So we're dividing both sides by negative 2. And we get a is minus 3. Now that we know that a is negative 3, we can put that back into this equation. So we've got 6 equals b take away negative 3 squared. Excuse me. Negative 3 squared is 9. So b take away 9 is 6. So we're going to add the 9 to give me b equals 15. Now if we go back up, the equation we were looking for was b minus x plus a all squared. Okay, so b minus x plus a all squared means that we've got 15 minus x plus minus 3 all squared. Now a plus and a minus like that, we should know make a minus. So 15 minus x take away 3 all squared. And that's how we do those questions that look like that.